In the forests of northern Scandinavia, where autumn usually lingers in a golden hush, a strange chill crept in. October 2025 brought an autumn unlike any in living memory. The leaves had barely begun to turn when the first icy winds swept through, catching everyone off guard. The air turned sharply cold, more like January than fall, and the ground froze solid, trapping vital mosses and lichens beneath ice. The earth, usually soft and damp, became unyielding overnight. Reindeer herders and villagers felt the change immediately. This was no gradual shift, but a sudden, biting freeze. Birds vanished early, rivers glazed with ice, and the routines of daily life were thrown into confusion. The first snow arrived as a heavy, urgent blanket, smothering the last signs of autumn. It fell relentlessly, transforming the landscape in a matter of hours. Firewood was gathered in haste as families rushed to prepare for a winter that had come far too soon. The usual preparations, done over weeks, were now compressed into frantic days. The community sensed that the natural order had been upended. Conversations turned to worry, and elders spoke of winters past, but none could recall a freeze so sudden. This was more than a local cold snap. It was the first sign of a much larger atmospheric drama. The sky itself seemed to brood, hinting at forces far beyond the village. The silence in the forests foreshadowed a coming event that would draw the world's attention: the freezing of the Baltic Sea, a phenomenon not seen in generations. The people of the north braced for a winter of rare severity, aware that their climate's balance had been disturbed. They wondered what other surprises the season might hold. The early frost was a stark reminder of how deeply interconnected our planet's climate truly is, and how quickly the familiar can become strange. As the cold deepened, a relentless chill swept across northern Europe, bringing with it a sense of foreboding and awe. Its icy reach extended over the Baltic Sea, a vast brackish body of water bordered by 9 nations, each with its own history and relationship to the sea. In mid-October, the Bay of Bothnia began to freeze, weeks ahead of schedule, stunning both locals and scientists alike. The transformation was so sudden that many were caught off guard, watching as familiar waters turned to ice almost overnight. By late November, ice in some areas was already a meter thick, a depth usually seen only at the very peak of winter, not at its beginning. The speed and scale of the freeze were unprecedented in living memory. The ice spread steadily south, transforming the once busy sea into a vast frozen expanse. Maritime traffic ground to a halt, with ships trapped or rerouted, and trade routes disrupted for weeks on end. This was the earliest freeze since the 1950s, a record that raised urgent questions about the stability of the region's climate and what the future might hold for those who depend on the sea. The Baltic has frozen before, but never so soon. The event echoed legendary winters of 1947 and 1987, when the sea became a symbol of nature's power and unpredictability. For scientists, it was a rare and valuable opportunity to study extreme conditions in real time, gathering data that could help explain the forces behind such rapid change. For coastal communities, the sea's transformation upended daily life and commerce. Fishermen, shopkeepers, and families all had to adapt quickly to a world where the harbor was locked in ice. The familiar sounds of water lapping at the shore gave way to the eerie groans and cracks of shifting ice, signaling the arrival of a new, uncertain season that few were prepared for. The Baltic's record early freeze was both a marvel and a warning, a dramatic sign of profound change underway, and a reminder of nature's ability to surprise, challenge, and reshape the world we know. What caused this extraordinary freeze? The answer lies in a convergence of powerful atmospheric forces. In autumn 2025, a weakened polar vortex, a persistent La Niña in the Pacific, and rapid Arctic warming combined to unleash Arctic air over Scandinavia. The polar vortex, usually a stable barrier, faltered early, letting frigid air spill south. La Niña altered the jet stream, steering cold air directly into Europe. Meanwhile, the warming Arctic released extra moisture, fueling heavy snowfalls that reinforced the cold. This rare alignment of global patterns set the stage for the Baltic's historic freeze. To understand the severity of 2025's cold, Look to the stratosphere, where the polar vortex spins. Normally this vortex locks Arctic air in place, shielding Europe from the worst of the cold. But in autumn 2025, a sudden stratospheric warming event shattered that barrier. The vortex's winds reversed, and Arctic air surged south, guided by a distorted jet stream. The result: a deep, persistent freeze over Scandinavia, with true polar air settling over cities like Helsinki and Stockholm. This wasn't just a cold snap, it was a wholesale shift in atmospheric systems. Scientists have linked declining Arctic sea ice to more frequent vortex disruptions. As the Barents Kara region warms, it sends waves into the stratosphere, destabilizing the vortex. The melting Arctic is making its own cold more likely to escape, with global consequences. The 2025 event was a vivid example of this new volatile reality. While the polar vortex unraveled, another force was at work: La Niña, cooling the Pacific and reshaping weather worldwide. La Niña's influence bent the jet stream, anchoring a high-pressure block over Greenland. This block diverted mild Atlantic air away from Europe, opening a direct path for Arctic cold. The timing was crucial. La Niña and a weak vortex combined to create a perfect storm for extreme cold in Europe. Such teleconnections show how distant climate events can trigger local extremes. The Baltic freeze of 2025 was a direct result of this global chain reaction. It's a reminder that weather in Europe can be shaped by ocean temperatures thousands of miles away. Understanding these links is key to predicting future extremes. The Pacific's chill was felt all the way to the frozen shores of the Baltic. The sudden cold and sea ice sent shockwaves through Nordic life and economies, creating an unprecedented challenge for the region. Shipping lanes in the Bay of Bothnia froze solid, halting trade in essential goods like steel, timber and paper, which are vital to the Nordic economy. Icebreakers rushed to free trapped vessels, but many ports shut down, costing millions in lost commerce and leaving many workers idle. On land, relentless blizzards buried roads and cut power to thousands, isolating communities and closing schools, making daily life a struggle. Air travel was severely disrupted, and daily routines shifted to survival mode, keeping homes warm, checking on neighbors, and clearing snow from paths and roofs. Yet, resilience shone through. Early ice roads connected remote islands, and the aurora borealis lit up the long, dark nights, offering a glimmer of hope. The Finnish sauna became a sanctuary, offering warmth, community, and a place to gather and share stories of endurance. The early freeze tested Nordic adaptability, but also revealed the strain of a climate out of sync, pushing communities to their limits. Amid hardship, moments of beauty and tradition persisted. As families gathered for traditional meals and children played in the snow under the northern lights, the region's response was a testament to both vulnerability and strength, showcasing the power of community and cooperation. The winter of 2025 became a story of disruption, adaptation, and endurance, a chapter that would be remembered for its challenges and triumphs. The lessons learned during this harsh winter would echo long after the ice melted, shaping the future of the Nordic region. The Baltic freeze was not an isolated event, it was part of a global pattern of climate disruption. The same weakened polar vortex linked to the Baltic's cold has been tied to droughts in India and deep freezes in Texas. As Arctic sea ice declines, monsoon rains in India falter, threatening food security for millions. In North America, a wavier jet stream brings Arctic air deep into the south, as seen in Texas's devastating 2021 freeze. These events are connected by shifts in atmospheric circulation, driven by a warming Arctic. Even military strategy is adapting. Joint exercises in the frozen Baltic test readiness for a changing climate. The world is learning that what happens in the Arctic doesn't stay in the Arctic. Our climate's volatility is now a global reality. It seems paradoxical, but a warming planet can bring more extreme cold. As the Arctic heats up, the jet stream weakens and meanders, letting polar air spill south and trapping weather systems in place. The loss of sea ice exposes warmer water, fueling heavier snowfalls when cold air passes overhead. The result, not just cold snaps, but crippling blizzards, as seen in Norway and Sweden in 2025. Scientists are now observing these changes in real time. New research shows that freezing processes are altering the chemistry of Arctic rivers, turning them orange as permafrost thaws. The landscape itself is changing, with unknown consequences for ecosystems like the Baltic. The Arctic's transformation is reshaping weather, water, and life, far beyond its borders. The cold of 2025 was not an anomaly, but a preview of what's to come. The paradox of more cold in a warming world is now a lived reality. The Baltic freeze of 2025 is more than a weather event, it's a warning. Our climate system is becoming less stable, less predictable, and more extreme. The early sea ice was a visceral sign that distant changes in the Arctic will reach us all. Climate models predict an ice-free Arctic summer as soon as 2035, a tipping point that could double the frequency of extreme cold snaps in Europe. The paradox of a hotter planet punctuated by severe cold is becoming the new normal. The events of 20,000 show that the past is no longer a reliable guide. We must accelerate our understanding and act to address the root cause: global warming. This means cutting emissions, shifting to sustainable energy, and protecting fragile ecosystems. The frozen Baltic is a reflection of our impact and a final plea to restore balance. The message from the ice is urgent. The time to act is now. Our future depends on what we do next.